from the 1950s till what is the state of the art now. I'll also get into some challenges specifically for Arabic NLP, since this is the topic of our discussion today. And also I will show you some state-of-the-arts, very state-of-the-art techniques, and finally I will conclude. So what is natural language processing, or NLP? NLP is actually a branch of artificial intelligence that helps computers understand, interpret, and manipulate human language. So NLP draws from multiple disciplines. It draws from computer science, from computational linguistics. It also aims to fill the gap between human communication and computer understanding. So it's that link between computers and humans. It's that interface between humans and computers. And actually, you can like separate NLP into two different sections or two different domains. One of them is natural language understanding, NLU, and the other is NLG, or natural language generation. And you can combine them both into coming under a great umbrella, which is the NLP. For NLU, natural language understanding, we can see that we can use it in sentiment analysis. I'll talk about it later. Question answering, some kind of question answering. We also use it for emotion classification. These are the names of currently used tasks. We use it for offensive language detection. There's also a task for named entity recognition. These are all the tasks that demand us to understand the text and just like do some classification, some outputting like one value from it. And you'll see later how we kind of approach these problems. And for generation, the tasks are trivial. Like we want to generate the response. It's a bit different than question answering. I'll talk about it. Want to generate a summary from a big text. Want to like have a model that, or have an algorithm that summarizes the big text, so it's easy to read and faster to read. Translation is actually it's actually a combination of NLU and NLG. So because we have to understand the text coming from one language and then translate it or generate text in another language. We can also consider image captioning, where we automatically generate or describe an image with text. This is one kind of natural language generation. So applications of NLP are, you see them daily, you encounter them daily, you interact with them daily. One of the most popular is email filters. Sorry, if you see in your inbox, go into your inbox, you find the spam filter. It's actually a statistical NLP technique. We'll see that a bit. That compares the word and usually spam emails and tries to predict if this email is a spam or not based on previous collected emails and collected data. This is actually one of the most widely used techniques that you encounter them daily. Also, another one is smart assistants, the one that you see on your phone, Google Assistant, Siri, Alexa. Those are we call them slot filling. So because they have like a form inside. So the form is like you want the chatbot, or you want the assistant to change your music. So you ask it, okay, I want to play Nancy Ajram. So the first task for this chatbot is to identify what is your intent. So what do you mean by it? Which task should it do? The task is here playing music, and then it will ask you, or will try to find what is the artist, or what is the name of the song that you want to play. That's a kind of classification or named entity recognition. So you want to recognize that named entity. And if the bot fails to recognize one of those, it will ask you. It can also infer from the context. So if it can detect that you are in a taxi, or if you are already ordering a taxi, so this information will help it figure out what is your intent, what actually do you want to do. Another application that I mentioned earlier is language translation. Language translation has been throughout the multiple development and evolution throughout the history. It first started in the 1950s with rule-based machine translation, which proved actually hard to write because there are too many rules. Language is hard actually and some concepts doesn't translate well between languages. Then we briefly moved to example-based machine translation, and then a big evolution was statistical machine translation, where it was where we compared actual phrases, syntax, and word. We'll talk about this later. And nowadays, the Google engine actually uses neuro machine translation because it became so good. Actually, it rivaled the human translation on some languages. And actually, like 1 month ago, let me just play this video. Facebook AI were actually able to create one engine, one model that was able to translate simultaneously 100 languages. So it understood 100 languages, and it was able to translate from one of them to another. Usually this is done using English data. So because we don't like encounter Nepali to Arabic translation pairs. So they usually, other companies or other models, they usually use English as a like to shift or to go through English and then go through to the other language. And this is currently done in the Google Translator that you see. But Facebook actually is one model that combined all of these languages in one model or in one engine, which was able to actually translate from any couple or any pair of these 100 languages. I'll let the video play a bit. So this was actually a big achievement, because for the first time we didn't rely on English, because relying on English it will actually bottleneck our learning a bit. So don't bother about the model. I will try to explain it later on. Another currently used techniques is sentiment analysis. Sentiment analysis is always used in like business applications. Some businesses would like to predict their stocks based on the sentiment of people towards like a company or towards like a product. So this way we'll need a sentiment analyzer to analyze those tweets, of ideas, those languages or those text circulating on social media. This is one of the main drivers of stock markets. You see, if you search about Bloomberg actually has the big dashboard that can analyze tweets and analyze social media to predict if we have to buy or sell stocks. Another use actually for sentiment analysis is the currently occurring U.S. election, where people try to predict which president or which person will win from the tweets or from the social media. And usually this works. This doesn't work much. This doesn't provide great results, because people don't often express their opinions online, or even negative people, they express more opinions more than positive people. So it will lead to some kind of biases against the candidate. But it proved that it is much better than the research that they do, where they go and ask each person on the street and they do some statistics. The sentiment analysis was able to better predict presidents and was better able to predict the sentiment of the US than these statistics and going out and asking people. So a bit of history of NLP. We can like divide NLP into two parts: the pre-deep learning or pre-artificial intelligence, and then the post-artificial or the current area, which is the deep learning area. It started in 1949 with a memorandum by Weaver that brought the idea of a computer-based application that can translate languages. I think it was for Russian to English translation. Then the people had to write rules to do these translations, but they didn't succeed very well. And then researchers progressively realized that the task was a lot harder than anticipated, and they needed a more adequate theory of language. And it took until 1957 to introduce the idea of generative grammar by Chomsky. I think it's popular, and it's a rule-based system of syntactic structure that brought insight to how mainstream linguists could help machine translation. And this is like the Chomsky area, or this is just Chomsky school of natural language processing, which nowadays we tend to distance ourselves from it, because it's so much rule-based, while the current NLP progress is data-driven. So everything is learned from the data, not from handwritten rules. Then conceptual ontologies came out in 1970s, followed by symbolic models in 1980s. I won't get much into those because they're a bit different from NLP. And then in 1990s, statistical models were introduced and helped boost NLP performance. By statistical models, I mean models like a word count, or we call a bag of words. So a problem in NLP is we want to represent this sentence by numbers that computers can understand. So for each sentence, you want to generate what we call a vector, or what we can call a collection of numbers that better represent this sentence. One of the first ideas was to just count the occurrences of words. So let's say this is our vocabulary. It's like 7 words. So the phrase or the sentence, it is a puppy, is represented by 3 ones, 3 starting ones, and then zeros and then ones. So we put 1 where we have a word and zeros where you don't have this word. It's actually a pretty simple idea. It kind of works for some stuff, but it's very basic because like the word it here, it is repeated in almost every sentence, and the word is here is repeated in almost every sentence. And then they actually don't add any information. So no information is added when we have the one under it here. Another idea came is an improvement of the word count idea, which is called TF-IDF. It's the same. We have to count frequencies of occurrences, but we then divide them on the occurrences of this word in all the documents. So the word or the letter I here, the word I here, is repeated multiple times in all the documents. So it shouldn't be relevant. So it doesn't add any uniqueness to this sentence per se. So here actually love isn't repeated at all. Is only repeated. Only occurs only in this first sentence. It doesn't occur in any sentence. So it must have value for this sentence specifically. And this is why we give it a higher score. And by this we have a better representation of a sentence. So now you can start to do sentiment analysis. So if you notice that like we have high scores for love, high scores for hate, you can say that this is positive and this is negative. But this sometimes fail. This cannot detect negation, for example. Also, any order order information between the word is lost. So if I say I love cats but I hate dogs, for this representation it's the same as saying I love dogs but I hate cats. So there is information lost here in this representation. Also, if we have a large number of vocabulary, so let's say English have about 30 million unique words. So here we have to have, like, for each sentence, we have to have 30 million numbers to represent only one sentence. This is not efficient. It's not even, your computer will basically break in about 1,000 sentences. Also, the idea behind these representations are that a word, you can always tell a word by the context or by the context that it keeps around it. And this is an idea by Firth, and the quote by Firth was, "The complete meaning of a word is always contextual, and no study of meaning apart from context can be taken seriously." This is one school of thought in NLP. The other one is the Chomsky school. But nowadays we're more steering into the Firth school of thought. Also, we have another new NLP techniques that we added, like stemming, lemmatization, and stop word removals. So basically here, the word I and my and is aren't necessary. So one idea is to like remove these, and we call them stop words, like the word and, they, the. We just remove them, we ignore them, they don't add any information. This is one idea. Also, another one is like, why have dog and dogs? If you want a simple representation, just put them, extract the stem or the lemma, and then put it into dog. Or instead of knitting, put the original verb in place. This is one idea to reduce this vocabulary. So the greater the reduction, the smaller the representation, the more tractable it is. And this is where actually deep learning comes in, and it tries to solve these problems. So first, Yoshua Bengio et al., they proposed the first neural language model. Yoshua Bengio is one of the godfathers of AI in general. They received the Turing Award. It's an award given for it's a very prestigious award given for the outstanding innovation in computer science. So Bengio first introduced neural language models in 2003. And these neural models are, they also introduce what is called the word embeddings, or these are word vectors or a collection of numbers, but they aren't like 30 million numbers. We only need like about 300 or 1,000 number to just model or to express the meaning of a single word. And then they had some kind of machine learning model where they trained it on predicting a missing word. And by predicting a missing word, they I don't want to get into details here because this is a non-technical introduction. So each of these numbers are chosen to represent the meaning based on the accompanying words, based on the context. So you can tell. So this here we come back to the quote, where we say that we can know a word by its context or by the friends that it keeps. So this is this is the first idea of neural or deep learning that was introduced for NLP. The other one came in 2008 by Colbert and Weston, and they suggested that let's try to solve multiple tasks at a single time. Instead of just predicting a missing word, let's try to predict the part of speech, or maybe try to predict which is a named entity and the semantic roles of each word at the same time. And maybe this model then will learn something about the language. So the goal here of NLP is to have a model, or to have like a black box for you. You have a black box that knows language, that actually can understand this language, or that can output a series of arrays or a series of numbers that are actually that carry meaning. So we need some kind of learning techniques or learning tasks to learn those numbers. And here, Mr. Colbert and Weston, they suggested using part of speech tags identification. And then Mikolov from Google and AI, of course, I think this was in 2013, yes. They popularized the actually most popular word embedding model. So this is how like a text is represented. So let's say we have the word man. It is represented by 300 numbers or 500 or 1,000 numbers, and each number and each collection of numbers will carry a meaning, just like the other stuff that I mentioned earlier. But this time the training was different, or actually the training was not different. It was more optimized. So they could actually train on I think all Wikipedia and some gigabytes of books. So here, let's see, this is one of the training procedures. So we select like a window of 5 words, and we remove the middle word, and the model will have to predict what is this missing word. So by predicting this word, while having the 2 other words on its right, it should learn, should be able to capture the meaning of brown. So brown usually comes with the, quick, fox, and jump. And if we take those numbers and we do some mathematical projection into just a 2D, we do some mathematical projection on the 2D space, we can actually see that some words are grouped together. So like man is close to woman, king is close to queen. I will show you now in a 3D representation also. And we can actually start doing some math on them. So the relationship between king and man is the same as between king and woman. This is one of their findings. The relationship between Paris and France is the same between London and England, between Rome and Italy. Also, yes, other types of relationship are there exists plural relationship. Here we have capitals. He himself, here the mother boy, mother daughter. We can, or father, what yani, What a girl is to a father is a son to a father. I will now show you a better demonstration. It's on a, I hope this loads. It's a projection in a 3D space where you can actually see how are these words grouped together. So this is actually 10,000 words. They are trained, I think, on Wikipedia and are projected in a 3D space. So now we'll see now the 3D space projection of these words. Okay, now they look like, okay, they're just randomly associated. So choose a word here. Let's say, I don't know, car. And then let's go and group them together. This is one of the algorithms that groups everything, that clusters everything together. Okay, let's finishing up. Now you should, I will try to zoom in because this might not be very visible to you. Now you'll see that the words start moving and getting clustered together. Don't worry about how it's done. And we should be able to see some clusters starting to emerge, or like branches. Let me pause it here. And this, so let's choose a good cluster. A cluster here is like calcium oxide. It's about chemistry and elements: sulfur, potassium, chloride, nitrogen oxidation. Another cluster is cartoonist, conductor, playwright, novelist, critic. So you can see how this like semantic association is closer. Or the words that are similar are more closer together. Cluster here is about computers. I think these are computer and microprocessor architectures, and so on and so forth. So this is one of the best representation of the word vectors. So let's say if you want to do some sentiment analysis, maybe the positive sentiments and negative sentiments are like two different clusters, and when we combine and when we train a model, or when we do some kind of some separation between them, you can actually differentiate between a negative tweet, let's say, or a positive tweet, just because they are differently located in this space here in front of us. So let me continue. Another one is in 2013. Also, we had some what's called the recurrent neural nets. It's an architecture that was introduced specifically for NLP, and what solved it solved the issue of order information. Remember the example of I love cats and I hate dogs, because even with these vectors, the no time relationship is present. So in order to represent this relationship, we needed a model that reads like humans. So humans go into words, or we think that humans go into words, into sentences, one word at a time. So it has to read the first word, then read the second word, then read the third word, and form a meaning out of it, and form actually a single vector or single representation out of these three words, read after each one after each other. So if we change the order here, the vector actually will change and the meaning will change. And then the model will have to read all the sentence, and at the end we can do some. Here I'm using a lot of sentiment analysis examples, so we can do some sentiment analysis. So here how we solve the time order problem, the time information problem, by having a model go through the text line by the word line word by word, and not like averaging all these words together, or having one representation for the whole sentence. Another idea that came to be, it's called the sequence-to-sequence learning. And this idea solved the problem where some tasks required us to generate some text from text. So like translation, like paraphrasing, like summarization. We have an input text and we want an output text. So it's a sequence to a sequence. So it's a mapping. We have to figure out some mapping. Even chatbots, let's say, we have to map an utterance to a response. And this way we needed some model that was able to do that. A simple model was a model that goes word by word through the input sentence. So here we're doing translation from English to German. The model goes line or word by word through the input sentence. It forms what's called the context vector or the thought vector. This vector, which is the same as we did initially, it contains the meaning of this whole sentence. And then using this vector, we pass it through another, what we call a decoder. And this decoder starts generating words based on the context in English. And the second model will learn how to generate words from a context, but in German. So it's, if you're somehow familiar with encoding and decoding, so where we compress and decompress, this is some kind of, this is a simple example. This is a very similar example, actually. Of course, I'm not. There is a lot of missing details here that I'm not going through. And in 2000, actually, this is 2015, I think. This is not 13. Mr. Bahadnau and Duong, two actually different papers, they introduced something we call attention. So instead, when we are decoding or we're predicting each word at a time, here we have one single vector to look at instead of looking at the whole sentence. We have one single vector or one single representation for this whole sentence. And this representation has to carry the weight or the meaning of the whole and the meaning of the whole sentence on its own. One single representation, 300 numbers, should carry the meaning of the whole sentence, which is hard to learn, which is hard for a model to be able to do. So they suggested that at each step of decoding, let the model look at each word in addition to looking at this context vector. So when we're generating like zoo here, we have to, the model looks at all the words before, and let's see that zoo may be correlated to 2. So this is kind of correlation between them. I will, it helps the model learn by re-looking at the English sentence. And then Vaswani in 2017 came in and said, so if we have some kind of mechanism that allows us to look at all these words and then generate some meaning from them, why do we need this this recurrency, this model that goes through each word at a time? Because just look at all the words all together, look at them all together, like from above, and then extract meaning from them at the same time without going through them one by one. This is what he called in this paper. It's called attention is all you need, which is basically self-explanatory. Because the attention here, we only need attention. We don't need any recurrencies. This is a revolutionary step in NLP, which happened in 2017, and it's also by Google. And then the resulting of it was a model that's called the transformer. I won't get into the details in the transformer, but I will introduce some other models that you might hear and you might see in the literature. And some of them, it's the most popular of them is BERT. If you encounter BERT in some kind of news article, BERT is the best encoder for language. So it's the best way that we have to understand language right now. Actually, Google in the beginning of this year started using BERT for all your Google searches. So whenever you type in on Google search about a question, about you want to search about something, on the back end, so on the Google servers, they're using a model called BERT that understands what you wrote and generates some kind of representation that is used to search all the web. And also 2018, this happened in 2018, an idea of pre-training a model emerged, where instead of starting for each task, let's say for sentence analysis on Arabic tweets, instead of starting from scratch from random numbers, why don't we start from a place that is more advanced, or from a model that knows better about the language, and then we fine tune it, we transform this, we fine tune it to understand sentiment by first having understood the language on its own. This is one of the main ideas in NLP recently, which is pre-training, and people are till now coming up with pre-training methods. Some of them are masked language modeling, where we predict a missing word. Some of them are like we get a sentence and we shuffle all the words, and the model has to reconstruct the sentence on its own. There are different pre-training techniques, and each of them has had its own advantages and disadvantages. So watch out when you see BERT in the literature. It's a pretty powerful model that will sure, I think it will sure form the next stages in NLP. I will also show you a model that might have made it into your news inbox. It's called the GPT-3. GPT-3, it's another model that is very similar to what we talked earlier. It is a huge model. It's around 175 billion parameter. To put that into perspective, you need like 10 laptops of probably your laptops just to download the model, and then to run it, you might need like half an hour to just predict one word. This model was trained on 300 billion words, so it's basically trained on the whole internet. From I think it's only in English. It also contains some code, some whatever is on the internet, it is trained on. So, and the task for training was predict the next word. So we give it here, recite the first law of robotics, and it should continue it, one word at a time, one word at a time. And actually, this model was able to learn many tasks that nobody anticipated. I will show you a quick use case of it. And up till now, this is like the early 2020s. And till now, people trying to figure out the new use cases for these models. One of them is continuing your Excel work. So it's loading. It's from a company called OpenAI. They work with Microsoft, and they work with, I think they work with Elon Musk. So one of the ideas, let me zoom in, was that given a table here and given a population, the model by itself will fill the missing population for Michigan. And remember that the model was only trained on predicting the next word. So it predicted that here, the population of Alaska is actually 600,000. This is somehow true, but it shows that the accuracy of the model is very good. It also was able to predict when the state or when the state was founded. Another task for it is like designing websites, because websites are basically text. So the website that you see in front of you, if you go into the inspect, it's actually text written. It's text that computer can understand. The model was able to actually predict these texts, and actually was able to build websites, and just by description. So the model, we said to the model here, I know it's not clear. We said I need a large text that says "Welcome to my newsletter," and the model actually generated a whole website that that says the same. Most of them are, if you're familiar with LaTeX, also the model was able to generate LaTeX text, search engines, they did everything. It was even able to write another neural deep learning model. So, and this is the first AI that was actually able to write AI. I know it's scary, but it's basically it's not very useful. It is useful, but it is more impressive than useful. So some people were afraid that this model might be able to replace developers and data scientists and people like us. I think it's not, hopefully. So now let me get into the Arabic NLP part. And here are some of the challenges that we encounter when we do Arabic NLP, which are different a bit from English NLP. Why? Because usually in Arabic we have to deal with dialects, and dialects, a big problem, a huge problem with dialects. We have multiple standards of writing, but when we have multiple standards of writing, then there is no standard. I will write like I will write the word fin بطريقة, you will write it another way. Even the same word will have two different and the same word will have two different meanings, or multiple meanings to have the same word. This is dialects are all over the place. And actually, there is a task in Arabic, it's called Dialect Identification. And recently, the best model for dialect identification was able to achieve only 27% accuracy on 21 dialects. So this is country level dialect, and even 6% accuracy on 100 dialects, which is these are city level dialects. So it's so bad. It's so hard to differentiate for a deep learning of artificial intelligence to differentiate between these dialects. And it's very hard to understand these dialects because we don't have much dialectal data available. We only have Twitter data, but it is very noisy, it is very short. We don't have books written in dialects. And another challenge in Arabic is the morphology. Arabic is a highly morphological language. How we form words is different from English. Because we can start from a three character word to form literally a basic sentence within one word. ويساعدونها, it's literally a sentence within one word. So we need some kind of models or some kind of techniques that help us segment those words into their basic components. We have stemming, lemmatization. These are two of them. We also have morphological analyzers. Two of the most popular ones are Farasa and Madamira. I encourage you to look them up. It might help you in your work. So these two tools, they can you give them one word and they can segment it into its like in the enclitics asides, the proclitics asides, the suffixes, the prefixes. It will try to segment it as much as it can. It's not perfect. There's some kind of it's not I think the accuracy is like 99.7% or 97%, if I'm mistaken, which and it only works on MSA, so on Model Standard Arabic. It doesn't work on dialect because again, dialect we have a hard time to understand the dialect. Another challenge that we face in Arabic NLP are the diacritics or tashkil. Actually, tashkil, each حركة or each diacritic is actually a character, even though it's above a character, but for the computer it's actually a character. So the word rahimun huna here is actually one character, 2, 3, 4, 5, 6, 7. It's 7 characters, not 4 for the computer. So this creates an issue that we have an increase of vocabulary. Remember when I said before that we don't want more vocabulary, we want less vocabulary. Having the word rahim occurring 17,000 times each time with a different diacritic on it will not help any model learn, because we only have the word rahim will maybe occur one time in all our maybe in all our text that we have. It will occur one time, so we'll only have one example of the word rahimun. So we're not likely to understand its meaning, and that's why currently we just ignore the diacritics. We just remove them, and it actually makes some sense because you were able to read this sentence without having diacritics. You were able to read it probably fluently. Maybe it's a bit hard, but you can actually read it. أريد أن أدرس اللغة العربية. I can actually read it without having diacritics, just because I know the language. I know what is the verb, subjects, فاعل, مفعول. I know the grammar of the language. Hence, I know how to diacritize the language. Also, there are some tools that will diacritize the text for you. They are fairly accurate, fairly good. They're very fast. So if whenever you want to use these tools, just type on Google diacritizer for Arabic, and you get a lot of them actually. Some of them you can directly use them, copy paste text, and you can easily use them. And actually, other works on dialects. We have the Madar project. It's a project that was started by the Abu Dhabi NYU University in Abu Dhabi, New York University in Abu Dhabi, and they intend to collect all the unique vocabulary, dialectal vocabulary. Let me show you. Oops. Let me show you their website. It's under the Madar project. Resources, lexicon view. They have multiple resources, but one of the most, I think the most interesting for you is the Madar lexicon. Here you can see and contribute with different different words that you find from different dialects, or you can also validate and review words. So you see how hotel, like there is like four different ways here to write the same word hotel, which means fonduk, and not these words are they like oversize our vocabulary. They blow up our vocabulary, which makes it very hard to actually do some NLP on Arabic. Another one is the Corpus View. Here are some collection. Let me zoom in a bit. Here are some collection of words, of sentences, and each sentence is labeled with the city. And we have a pair of sentences. One is in standard Arabic and one is dialectal. So it's like translated. This can help in translation tasks. There's actually dialectal translation, and it's not a very popular task in Arabic NLP because of data, but I think it's one of the hardest and the most it should be the most requested one, because translating between dialects or even from dialect to MSA to standard Arabic is of a great use. So also you notice that here all the sentence there is no diacritics again, and these translations, they might be a bit noisy, they might contain some issues, but most of them are very well filtered. I've tried to find a different city. So this is on a city level. The dialects are very hard actually problem to solve, because from my experience, like my village here, we speak a dialect, and the village next to us, they have different vocabulary. Why? I don't know, but it's a very hard problem to solve for us. Also, there is also the work on morphology that I talked about earlier. The popular tools that you can use are there's a Gumar corpus and there's the Madamira morphologic analyzer. Let me show you the Madamira analyzer. This might be interesting to you. Madamira. Actually, you can try the tool here if you want, and you see how it performs, how it can do. It can do some. Let's start with part of speech. It's in Arabic or English? Maybe in Arabic. So the input word was okay. Let's get an Arabic sentence. Arabic. Okay. So this is the output of the tool. It removed the al-ta'rif, It also shows you like the word قائمة ما نوع الكلمة أنه اسم الأعراب مرفوع it's a female عدد مفرد التعريف نكرة and it also shows you the English translation for it. The English translation might not be very accurate but it's sometimes helpful. The word hattrick it's a word from English that is it was actually translated to Arabic. It recognizes that it's اسم علم which is wrong. It's a مذكر مفرد. So it shows you multiple outputs. Here it knows that this is a فعل ماضي مذكر مبني. So this is good tool for الأعراب يعني القواعد. تصنيف الكلمة here it shows you only the تصنيف الكلمات part. It can do diacritization. So قائمة مثلا here it made a mistake قائمة الهاتريك this should be قائمة الهاتريك في كأس العالمي لكرة القدم وهي قائمة المباريات and it continued well. This is one of the المدخل المعجمي not also this is different representation of the output. Named entity if you show it like let's see like a place named entities are like locations person names. Here it should be able to tell. Okay, so it was actually able to recognize that the Bert Battinud was a شخص, a person, and منتخب a place, but it failed to recognize that الولايات المتحدة is a place. Because probably this is a composed word, so it's hard sometimes to detect. Let's see. التشكيل here. يعتبر اللاعب مظبوط التشكيل here. Also another tool is فراسة on this website. فراسة. فراسة دم. This is a tool that is a bit faster and it provides some of the same functionalities. So it also segmented the word into morphologic segmentation of the word. This is very helpful actually to reduce the vocabulary and to reduce the vocabulary. Reduce the vocabulary. Also, it can do some spell checks. Spell checking for Arabic is a good research area for us because we know Grammarly for English. For Arabic we don't have this kind of advanced tools. We'll be needing them soon. I think there's some work on it. So here متحدثوها. متحدثوها. It's actually right. I don't know why I put it wrong. Part of speech, which was shown. So it actually able to recognize verbs, preposition, nouns, adjectives. So it shows you actually if it's plural, singular, or if it doesn't know. Gender also was found. Diacritization. Diacritization is actually good here. Let's see. Dependency parsing is one of the problems. This should be displayed as a tree. So which words relates to which other word? Named entity recognition. Here it was able to recognize that these are locations. الوطن العربي. I think الوطن العربي it was mistaken here. It is a name. Here it's an organization. Arab. Let's see. This should be displayed as a tree because like here it's very hard to see. So Faras as another tool. Also Another tool for morphological analysis is called SADI tool, but there's no demo available online. One of the last tools that I want to talk about is Arabert, which is, or basically language representation models. The first of them for Arabic, remember those word vectors. We have word vectors trained on Wikipedia and Twitter, about 1 million of unique words. It's called the Aravec. Another one from recently made from Mazajak, also trained on Twitter to predict the missing word on Twitter. And these are all available freely. So if you want to go into Arabic NLP, into AI and NLP, I highly suggest you start using those as your base pre-trained word vectors. And lately, an Arabic BERT version of the Google one that was released appeared. It's actually one of my work and my colleagues' work. And we present here contextualized word representation. So here, the representation of a word will vary with the context. So we don't have actually a word. How will I explain it for you? So in Aravec and in Mazajak, you find a word and you find one representation for it. In Arabert, no, you have to enter the full sentence, and based on this sentence, you'll get a simple representation for each word. We trained it on 3 billion words. It's actually trained on Wikipedia. Arabic Wikipedia is very small. It's about a gigabyte. And we trained it on 24 gigabytes of text. So it's text from news articles from all over the Arab region. So from Maghreb to UAE, basically. It's news articles from, let's say, Al-Nahar, Al-Akhbar, major news outlets. And we actually was able to achieve state of the art on almost every Arabic NLP test that we tried it for. Let me show you Arabic. And this is the results that we have. This is the result that we only published. Where the first 5 here, or the first 5 are only sentiment analysis, and we were able to achieve the highest score on sentiment analysis compared to previous state-of-the-art models. And also for named entity recognition, we were able to achieve high scores. For question answering, yes, for question answering, I was saying that in NLP, we have 2 kinds of question answering. The first kind is extractive question answering, where you have the answer in a long paragraph, and just want to see where is the answer in this paragraph. And the other one is the abstractive question answering, which is you ask a question and the model has to generate a totally new answer from its knowledge. So it's kind of like a chatbot. So this is here, it's an abstractive question. It's an extractive question answering. So we have it's trained on Wikipedia. So basically you have a text from Wikipedia and a question, and you extract an answer from it. You can actually see this behavior if you ask a question on Google. So let's say, how old is Obama, let's say? And the answer is 59 years. It's because it read it from the Wikipedia extract of Obama, and it knows that it is 59 years. So it selected it from there. It extracted it from there. And that's it. Basically, the conclusion of our workshop today is that NLP is basically everywhere. And the ultimate goal of NLP is beating the Turing test. The Turing test, for those of you that don't know, is it was created, I think, in 1950, I think, by Alan Turing. It was a test that says that if you converse with an entity, so if you just sat down and conversed with some kind of entity, and if you couldn't tell if this entity was a human or a bot, then the bot was able to fool you. And the bot passed the Turing test. So the bot should be able to fool the human of thinking it was a human, or should make the human perplexed and doesn't know if it's a human or a bot. At the end, I wanted to link. It's a recent interview with Walid Saba. Walid Saba is actually on the other kind of on the other school of NLP. So here everything that I said is data driven. So we extract knowledge from the data, Walid Saba is on the side of Chomsky, of the Chomsky school. They don't believe that actually data is the answer. It's another school of thought. So I highly recommend watching this interview with Walid Saba. It's highly insightful on the world of NLP and what should we do to progress more? Should we just go bigger with our models so we get more data? I don't know. So I highly encourage you to watch this. And thank you. So if you have any questions, feel free.
Shukran, Ustad Anton, for such an informative presentation. It's indeed very useful, I think, and it's inspiring for those who like to proceed with their MAs and PhDs in this area. I have some questions. Have you ever worked with Moses Technologies?
No, for translation. I think it's
Yes.
for translation. Yes.
Yes.
Yeah. Yes. No. I didn't. Right now, for translation, right now we're treating it like a sequence sequence to sequence. So you enter a sentence, and the model should spit out another sentence. So
yeah, because my master and PhD are in neural and statistical MT, so I thought of incorporating what I have learned from you today. Do you think neural MT and is going to be needed by companies in the future and
yes,
those who specialize in MT?
Neural LMT is everywhere now. I think Google transformed to neural
Yes.
models in 2008. If I'm not mistaken, in 2018 they totally went neural. They stopped everything and they went totally neural. Of course, they have some rules on the post processing rules to ensure that the output actually is not wrong, but it's fine till nowadays.
And do you think we will be in need for specialists in this area, or it can be covered by anyone who speaks English?
Right now, like NLP researchers like me, we just treat text like it's data, like it's just numbers. But after watching this interview here, I started thinking differently. Because you need linguists, you need language knowledge actually to improve or to understand text. And again, I highly recommend watching this interview. I will try to link it somehow. It's 2 hours. I know it's long. Treat it like a podcast. So we might actually need language theory and linguists to continue forward.
Yeah, because I'm a translator and I am thinking if I proceeded with NLP and AI, I wonder whether my expertise would be needed by companies if I'm going to work elsewhere. So your response is really helpful. For I guess companies who would like to go for testing or clients, I think sentiment analysis, they will still need NLP, right?
Yeah,
Guessing
sure.
information.
At the end, I think we'll need the linguists for validating what we learn. So right now, we just throw numbers. Okay, I show you here that we have the highest scores. Where okay, I don't have anymore. So we achieved high scores. Okay, and then what? Did your model actually understood language? I don't know. We need linguists to design some tests so we can test these models on.
Yeah.
There are many tests nowadays for most of them are predicting the next word, and we'll see how much the model is good at predicting the words. Another thing for translation, a big problem is how we assess translation quality. So right now the model is the performance of the model is assessed by counting how much of the word it guessed correctly. But sometimes I will write a different translation than you, and both of these translations are actually correct. So there is no way now to actually write this performance in numbers. This is one of the main
because
problems.
translation quality is highly distributed topic because it's understood differently in the industry.
Yep.
But I think metrics work on calculating and comparing source text with a reference text translation, and based on that, errors are analyzed by another metric, which is, I think, TER. But yes, I think clients' comments are needed, and research is actually should be encouraged in this area, especially Arabic NLP, because I think it's still in need of more research.
Yep, Arabic NLP, especially because when we go online, when we search how much Arabic people we have on Earth, we have like 400 million Arabic speaking people. And then we look at the research output of Arabic NLP, it's like there, English, we have English, Chinese, Spanish, French, whatever you want, and then Arabic at the end. My goal when I joined NLP is like, I wanted to bridge this gap between Arabic and actually put us on the map of NLP, not just only English and Chinese and Spanish.
What about Corpus Tools and collecting and preparing corpus material for further research in NLP? I think also we are one of the low resource languages. Languages.
Yes, our biggest annotated data sets are like, I think maximum 100,000 compared to English, we have millions and tens of millions. Even the existing text for Arabic, okay, we have, I think, 90 gigabytes of text for Arabic. English, they have 2 terabytes, maybe more. 2 terabytes, like 2,000 gigabytes. So just readily available text. Yeah, we have Arabic content on the web is mostly on Facebook and on Twitter. It's not in like, we don't have like Reddit, we don't have forums where Arabs actually converse well with each other. They're not very popular.
Yeah.
Like I went to some Muntadayat to try to extract data from there. I just couldn't. The data isn't of good quality actually.
Yeah, it's a problem because I thought when I was an MA student to conduct research on different types of translation, and the only corpus I found to train an MT, specialized MT, was the United Nations corpus.
United Nations corpus,
parallel one. Yeah, it was the only one.
Actually, in my master thesis, I wanted to do a chatbot that is purely trained on data. I couldn't find any chatbot data in Arabic. It is large, so I ended up using the movie subtitles data, and I treated every 2 sentences as a query and response, and it actually did kind of good. Yeah, this is the reality that we live in compared to English, where they train on, because you can go onto Reddit and there's forums, so you can treat each question and reply as a query and utterance and response. So this is actually their training data, but for Arabic we don't have that. And also the Arabic subtitles are translated from English, so it's not like natural Arabic. That's a big problem with it.
Yeah, that's another issue indeed. Any questions from attendees, please? You can post them in the Q&A.
Also, if you want anything from me, you can ask me on my Twitter or send me an email. I'll be more happy to respond.
Thank you. There is a question. I'm working in a project for automatic recognition of discourse markers within English text produced by Arabic learners. Could you recommend tools or techniques that may help? I tried to use Python to code to build contextual parameters that assist machine to decide, but many problems arise.
I'm trying to understand the problem. Sorry, I never heard of this problem before. Automatic recognition of discourse markers. What do you mean by it?
Yeah, I think this is an English teacher or someone specialized in language. Yeah, but can you please specify what is discourse marker, Mr. Abdullah? What do you mean by discourse markers, please?
And if it's for Arabic, use Arabert. It's probably will help you.
Yeah. Yeah. So Mr. Wissam. Anton recommended Arbert, I guess.
Arbert, go into Arbert. There is a Python code there. Where is it? So if it's a classification problem, you can go into Arbert and the examples folder, and you will find I think it's like a name. So it's a token classification problem where you want to classify each token as being a discourse marker, yes or no. So take a look at the once it goes in at the NER notebook. It's a Python notebook for named entity recognition. And if the problem is similar, just use it and change the data once it opens.
Okay, thank you.
I hope I understood your question correctly.
What about speech recognition research? Is it one of the directions that you will work on in the future?
Actually, for me, I know, but for speech recognition, I think in Qatar and QCRI,
Yeah.
in QCRI they have the best tools for Arabic speech recognition, and I know they are working on updating their models to the more state-of-the-art models. I have a friend that is working on them, and from what I know from him, they're working hard on solving this problem for Arabic. I think their diacritics are important when we in speech recognition or in automatic speech recognition. It's good to include diacritics. But again, on dialects, it's hard. We tried
Yes,
the
of course.
dialectal. Google, I think they have dialectal.
Can you hear me? Is it an internet connection on my part or Mr. Wissam's part? I guess it's an internet connection on Mr. Wissam's part. He may join us in a couple of minutes.
Hi,
Sorry,
Asma.
Mr.
Sorry,
Wissam, I think we had an
internet cut off.
Yeah.
Sorry.
I think we have an internet connection problem. It's okay, it happens. Well, thank you for being with us. Any questions? Any questions from our attendees? They are telling you that this is a very interesting session and very informative. Actually, thank you very, very, very much for this detailed, informative.
For inviting me.
Do you have any questions? Please post them in the Q&A area so I can read them to Mr. Wissam. Mr. Abdul Aziz is saying thank you very much.
Again, sorry.
Mr. Abdulaziz has asked you how can we contact you?
Yeah, let me send my email. My email is wissam.antoon@gmail.com. Let me paste it in the chat. Where's the chat? So these are my socials. So connect with me on Twitter or by email. Anything. I'm more than happy to answer.
Thank you so much, Mr. Wissam, for joining us today. And thanks goes first and foremost to PSU and Applied Linguistics Research Lab for organizing this enlightening symposium. Thank you for our attendees for joining us, and inshallah we will see you in the future in inshallah, longer workshops, Mr. Wissam, and for the
Thank you.
attendees to join us in another set of activities. Thank you all, and see you, inshallah, in other events. مع السلامة.
Bye-bye.
Bye.